Okay guys, so you should have already taken this Univariate Statistics Formative Assessment. Since I'm not here, I made a video so that you can kind of see how it was done and also grade yourself, okay? Remember to use this form as your grade, and you should have had those handed out when you were done with the test or grabbed one, okay? So we've got 3 different standards here with 4 different learning targets, okay? And the problems, let's see, did I update them? Yeah. So make sure you mark off the problems as you go. If you get them wrong, right, mark it off, put how many out of that amount that you would have, okay? And then make sure to answer those questions as well after you go through all of this, okay? So you should be filling that out, and then I want you to hand in everything when you're done filling it all out, and then when I get back next time we will talk about it. All right, so let's take a look at this. So first thing we want to do is make some dot plots for questions 1 and 2, okay? So dot plots are pretty easy. We just make a number line, okay? And you could have done this in your calculator, so it might look slightly different if you did it in your calculator, but we can see our lowest is 19 and our highest 34, so I need to go from 19 to 34. Here's 25, 30, 35. Okay, so then we have 1 at 19. Okay, then 23. There's 1. 25 is 1. 26 and 27. 30, 31, 33. Finally 34. So that's a pretty simple dot plot, right? Because there's only one each. All right, now if we do number 2, same idea. Looks like we go 5, 6, 7, 8, 9, 10, and 11. I think that's the highest we go. So 1 at 5, so draw a dot for 5. 1 at 6, draw a dot for 6. 3 at 7, so 3 dots now. 4 at 8. 2 at 9. 3 at 10. And 2 at 11. Okay, so that's how we do our dot plots. You can also do it on the calculator, but I'll show at the end. I'll just have one example where I go through all 3 different types of plots. Okay, histogram. For a histogram, we need to basically do that, right? It's also good to do a frequency table. Okay, so let's see, we go 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. Let's see if that's enough. So I have no 0, so I have 1, 2, 3, 4, 5, 6, 7 ones. I have 1, 2, and then hold on, what did I do? That should have been 2. And that should have been 1. And then I have, for 5, we have 2. Okay, so at 1, we go clear up to 7. So this would be representative of the 1s. Then 2, there was just one of them. Actually, go like this. And then at 5, there was 2. So simple histogram, something like that. Now, yours may look slightly different, but it's that idea of did you get the right amount for the right one, okay? Goals in hockey, same idea. We've got 3, so 1, 2, 3, 4 of those. 1, 4. 1, 2, 3, 4, 5 5s. No 6s. 7 and 8, right? Let's do that a little better. 7 and 8. There's 1, 2, 3, 4 7s and 1 8. So we go 1, 2, 3, 4, 5, 6, 7, and 8. And we go up to 8. Oh, nope, there's only one 8, wasn't there? All right, this is the frequency that we have them. This is our number. Okay, so 5 was my highest. Okay, so there weren't any until we got to 3, right? And there were 4. And then at 4, there was 1. And then at 5, there were 5. 6 had 0. 7 had 4. And 8 had 1. Now I think these ones are probably the best ones to use the calculators for making the histograms. Okay, I think that's our best option when it comes to the histograms, is using the calculator. All right, okay. Now, let's see, we need 5 and 6, don't we? Here we go, there's 5 and 6. So now we want a box and whisker plot, okay? So remember, for box and whisker plot, we need to get some data first, don't we? We need to know the highest, the third quartile, the median, the first quartile, and the lowest. Okay, so looking at this, the highest seems to be 82.3. The lowest, 49.5. Okay, so there's our low, there's our high, and we probably want to put these in order, don't we? Just realized that my highest was actually 83, wasn't it? So when I put them all in order, we find the median first by eliminating a high and a low, right? So we get 75.7. Then that becomes our halfway marker. We do it again, and we get our first quartile, 61.5, and our second quartile, 79.8. Then we make our number line. So we start out here at 50, 60, 70, 80. Okay. So then my lowest, we draw a line, 49.5, about right there. Highest, we draw a line, 83. Then our first quartile, another line, 61.5. Median, 75.7. $79.8. Then connect the box, and finally connect the whiskers. Okay, and there's our box and whisker plot. I think we'll do this one in the calculator too to see an example of it in the calculator. Okay, let's do the other one now. So first thing I need to do is get my data in order. Okay, so there's my data in order. So my lowest is 2, highest is 23. Okay, we don't need those covered anymore. Then find our median, too high, too low, too low, too high, too high, too low, 1 and 1, so we get 12 for our median. And that's our halfway point, so going back the other way, 1, 2, 3, 1, 2, 3, 15 for our third quartile, and 4 for our first quartile. Okay, so then starting out at 0, 5, 10, 15, 20, 25. So high of 23, draw a line. Low of 2, draw a line. Third quartile 15, median 12, first quartile 4, first to third connected, then draw the whiskers. Okay, and it looks something like that. Okay, all right, so we're taking a look at this problem here on the formative assessment. Okay, we decided we'd look at number 5, I believe. So remember, this works for any of the problems. Okay, so dot plot, histogram, all that. Okay, so first thing we want to do is go to new document. Okay, go down to data and statistics. We need a list, so control doc, which is that plus page above the doc. Add a listen spreadsheet, label it. It was life expectancy, so we're just going to write life. Okay, then we just enter in our data. So 64, 77.8. You can just hit enter each time, 75.7. You don't have to put it in order when you're doing it on the calculator. Okay, you just put in all this data. Okay, then there's a few things we can actually do here. Okay, first thing we can do if we want to find out some of the information about this is you go menu, statistics, stat calculations, one variable. We're dealing with one list. What's our list called? It's called life. Put it in the C columns, good. Hit OK, and I can see my mean. I can go down and see that minimum, first quartile, medium, third quartile, maximum. So if I wanted to just use that to draw the box and whisker, welcome to do it. If not, we go over here. Oops. Hit cancel. I don't know what happened there. Okay, now we go down here to the bottom where it says click to add variable. So I click, I add the variable life, and there's my dot plot. Okay, so if all I had to do is make a dot plot, I'm done. I've made my dot plot, so we're good to go. Okay, now if I want to do a different one, I can hit menu, plot type, and we can do a histogram. That was the second one we were supposed to do. Okay, and there's our histogram. Okay, notice the frequency on the left side of the screen telling you how many are in each category. Then finally, if we wanted a box and whisker plot or just a box plot, we go down to number 2, box plot, hit enter, and we see our box plot. Okay, and if we hover over, we can see all those important numbers: highest, first quartile, median, first quartile and third quartile, and 4.9. Now let's say I'm gonna try to do something here. Okay, just wanted to touch one piece of data, but it looks like it's not letting me. Let's see if I can adjust this. Okay, as I change, I'm actually adjusting my numbers. And let's say the smallest one, about a 55. Okay, let's say that was 23 instead. Okay, now let's change this, click that again. Okay, now if you see something like this where you have a dot clear out here, that's an outlier. Okay, so that box plot is a great way to see the outlier, but that's how we do our plots. Alright, so that was learning target 1.1, so make sure you're scoring yourself on that. Let's move on to 2.1. Now we want to find the mean, median, interquartile range, and outliers of a given data. Okay, so we've got 1, 2, 3, 4, 5, and 6. Okay, so to do this, okay, remember the mean is the one when we add them all up and then we find out what they are. Okay, so let's take a look at these. Now, not necessarily the easiest data to work with, but it is already in order, so that helps things. So for like number 8, we can easily find the median, right? just find that one that's in the middle. So our median is 12,087. Okay, which then we can also find the first quartile, which would be in between these two. Third quartile in between these two. The reason we need the quartiles is to figure out the interquartile range and outliers. So, to find, when we have two numbers, right, to find that quartile, we take the two numbers, add them together, like I added those two together and got 95,103. Divide that by 2, and we get, for our third quartile, 47,551.5. Then I do the same thing for that. So 3404 plus 4095 divided by 2, and we get 3749.5. So to find the interquartile range, I take that third quartile and I subtract the first quartile from it, giving us, should be 43,802. Okay. Now, the way we find outliers is what we're going to do. Let me do this to help visualize it. Okay, so we've got the 3749.5, and then we've got the 47,551.5. Okay, so I take this and I times it by 1.5. So 43,802 times 1.5. Then I take that number, 65,703, okay, and I'm going to subtract it from that number to give me my low range. Add it to this number to give me my upper range. If anything is below it, it's an outlier, or above it, it's an outlier, okay? Well, 3,749.5 minus 65,000 definitely is in the negative, which that's not going to matter, so that's not going to do anything from that side. However, if we take the 47,551.5 and add it, we get 113,000, oops, set my eraser on, 113,254.5. And that one is definitely outside of it, so that would be our outlier. Okay, so 436,618, that is our outlier. Now to find the mean, we add them all up, divide them by how many there are, and in this case we end up with 64,234.1. And it's 0.1 repeated, but you can round if you would like to. Okay, so doing these ones by hand can be a little trickier, and I will again show you how we can do it using the calculator, but first we'll go back to 7 and we'll do that one with the calculator, okay? But let's take a look at number 9. So now we've got a histogram, okay, and well, this isn't really a histogram, is it? Yes, it's flipped on its side. No. So let's see what we've got here. So it looks like these must be out of 15 women, and it's their shoe size, okay? So we've got a 5.5, 2 6s, 3 6.5s, 2 7s, an 8.5, 1, an 8, 1, 3 9s, and a 9.5, and a 10, okay? So let's find the median shoe range, okay? So it'd probably help to write this one out a little better. So 5.5, 6, 6, 6.5, 6.5, 6.5. So this one exactly isn't a histogram, is it? 7, 7. That's all right, though. We can still do it. 8.5, 8, 3 9s, a 9.5, and a 10. Okay? So we can add all those together. We get 114. Divide that by 15, right? and we get the mean of 7.6. Now to find the median, right, we've got 3 below, 3 above, 3 below, 3 above, and so in between 7, oh wait, nope, that was a 7 and then 8.5, so 7 is our median. Okay, now to find our interquartile range, we find the first quartile, so the median. So I've got 1 below, 1 above, below and above, and so we get 6.5 for our first quartile. Third quartile, we do the same thing, 1 here, 1 there, 1 there, 1 there, and we get 9 for our third quartile. Okay, so 9 minus 6.5, that's pretty easy, right? 2.5. So interquartile range of 2.5. Now I'm going to take that 2.5 and I'm going to times it by 1.5. Oops. We get 3.75. So then I go below. So 6.5 minus 3.75 gives me a 2.75. There's definitely no shoe sizes below that, so no outliers to the left. To the right, we take the 9 and go 9 plus 3.75 to get 12.75. Nobody's above that, so there are no outliers in this case, which happens sometimes. Okay. Now, number 10, using the dot plot here, so there's 1, 5, 4 6s, so that would add up to 24. 6 7s, so that'd be 42. 4 8s, 32. Sometimes this can be helpful to add them up for the mean if you're doing it by hand, especially. 4 and 4 is 8, and 5 is 13. 3, 6, 103, divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 103 divided by 15 gives us about 6.87 or 6.9 when we round. Okay. Then we find our median, right? So one from the bottom, from the top, bottom and top. So I'm just dot plot to make it kind of easy, and I can see right off the bat it's going to be 7. Okay, so there's my median. Now we find the lower half of the data, which is 6. So there's our first quartile is 6. Our third quartile is going to be 8. So interquartile range, 8 minus 2, or 8 minus 6, which is 2. I take 2 and go times it by 1.5. We get 3. So if I subtract 3 from 6, that's 3. Nothing's lower than 3. Take 8, add 3 to 8, that's 11. Nothing's higher than that. So there are no outliers in that case. All right, number 11, this one's even easier to see because we've got a box and whisker. So our median here is this one. So that's going to be 7. Our interquartile range, okay, we're going from 6.5 here, which is our first quartile, to 8.5 here. So 8.5 minus 6.5 is 2. Find an outlier. We take 2, we times it by 1.5, so we get 3. So if I add 3 to 8.5, we get 11.5. Our highest was 10, so no outliers to the right. We subtract by 3. 6.5 would be 3.5, which our lowest is 5.5. So no outliers. Okay, now to find the mean, it's kind of close to the median. We've got a few high numbers, okay, which are going to drag it up here. So I kind of want to estimate about what I think the middle would be, and I'd probably go about 8. With just a box plot without the numbers, hard to find the mean. If we have the numbers, we can find the mean pretty easily. Okay, then number 12. So we've got, let's add these all up. Notice that they're counting by 2's here. Okay, so this would actually be 16, 20, and 24. So add them up, and you should have got 240, which we divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So 240 divided by 13 gives us about 18.46, or we can just put 18.5. Notice though, the way I marked them off, we also found our median here, which was at 20. Okay, then interquartile range, so I take the third half of data. It's in between 20 and 22, so it'd be 21 minus. Then I get rid of the other half of data. It's in between 16 and 16, so it's 16. 21 minus 16 would give us 5. I take 5 and times it by 1.5. I get 7.5. So if I add 7.5 here, I get 28.5. Nothing is higher than 28.5, which would be over here, so no outliers above. Subtract it from 16. 16 minus 7.5, and I should know that one in my head, 8.5. 8.5 would be here, so no outliers there. All right, here we go. So we are taking a look at question number 7, injuries due to distracted driving per month. Finding the mean, median, interquartile range, and if there's any outliers. So we want to go to new document, data statistics, control doc, lists and spreadsheets, name it. So let's just say injuries, so INJ for injuries. Okay, then I enter in my data, which sometimes can take a while. So we just put in each number. It doesn't matter the order I put them in. I'm actually going vertically when it's probably in order if I go the other way. With the calculator, doesn't matter. So we enter it in. Okay, so 15 items here. Now, we can go over here and we hit menu, go statistics, stat calculations, one variable statistics. I've only got one list, so I hit OK. I go up here, choose my list, INJ, column C works for me. Okay. Now, when I look at this, this right here is going to be my mean. Okay. That weird symbol, that X bar, that's my mean. Okay. So 7,872. Now, if we scroll down, okay, we see we've got our minimum number, our first quartile, third quartile, and our median. Okay, so our median, 7,805. Now, to find that interquartile range, we've got our two numbers right here. So what I'm going to do is, if I hit this button over here, right there, you see that? I can pull up my scratch pad. Okay, I hit escape, goes away. So I take 9153, so 9153, subtract 6734, 6734, hit enter. So there's my interquartile range, was 2419. Okay, hit escape again. Now, to find the outliers, I could do it by hand now, or if I go back here, I can actually graph it. Okay, there's my dot plot. If I go menu, plot type, if I choose that box plot, okay, it's going to show me if there's any. I don't see any circles here, so there's no outliers. Okay, if there were, so for example, if I go down here and let's take this number and make it super big. Okay, then let me go here and click. Anytime you change anything, you have to hit injuries again. Okay, see, let me actually pull it a little closer. You can go menu. Anytime you need to, you can go zoom data, and that'll help out a little bit. See, I went way high. Not really made things. Okay, usually it'll look more something like this. Okay, and even we can go a little bit closer. There we go. So anytime you see this, then that tells you, yes, you have an outlier. In our case, we didn't. But when you see it out here this far, yes, you do. Because notice as it gets closer, okay, we get to that point where it isn't an outlier. But once we hit a certain point away, then we definitely have an outlier. And we can even, see an outlier on the other end. if it was really low as well. So as we can see, we had a mean of 78.72, median of 78.05, interquartile range of 24.19, and then we had no outliers on that one. Okay? All right, so now let's take a look at kind of just comparison. Okay? So, look at the data presented in the following histograms. Which comparison is true? Okay, so we're looking at means and medians. So, when we're just comparing, if you have something that's further out, that's going to affect it. If you have kind of that normal curve, generally things are going to be more like the mean and the median. For data set 2, I would say would be about here at 7. If I'm looking at data set 1, it would kind of pull it slightly, but it's probably going to be similar to close between 5 and 6, okay, for the mean and the median. So on this one, our answer was going to be D. Data set 2 has both a smaller mean and a smaller median than data set 1. Okay. Number 14, now we got 2 more data sets. Okay. Again, looking at the larger mean and medians. And this one we could actually calculate them pretty easily, couldn't we? So if we calculate it, we get... So I calculated it, and we can see, based on that, data set 1 has a smaller mean, but a larger median than data set 2. Okay? So that would be, answer would be, looks like it would be B, right? Data set 2 has a larger mean, but a smaller median. Okay? And we can kind of see that because of how much more concentrated this is right here, that we're, a lot of numbers right there and right there. So that's what gives it a high median, okay? But quite a few smaller, which brings down the mean. Whereas you've got a couple really high ones up here that are kind of pulling that mean up, and then it's just a little bit more spread out, okay? All right. 15 says, what about these ones? Which comparison is true? Again, we want to probably find them. So we'd have the mean and the median. Again, the mean and the median. Okay? So we can add them all up, divide them, and then do the other stuff too. All right, looking at number 15, and you could maybe see this because it just seemed like the numbers were lower on data set 2, that they're both. The mean and the median are both lower for data set 2, which if you look at our answer, we didn't really have that one, right? So definitely data set has a smaller mean, and it also has a smaller median, okay? So must have been a typo and didn't get that changed. I apologize for that. Happens sometimes. So if you put E, data set 2 is smaller on both, that would have been the correct answer. And remember, it's if you recognize and know this, not so much if you got the question quote unquote right. It's all about that learning. Also on number 16, those numbers shouldn't be there. I forgot to erase them apparently. So from a different problem that I was doing, trying to create a couple problems. So hopefully your guest teacher will have told you that. So it says, here are the test scores from, wow, there's all sorts of issues here, huh? From a statistics class. If the highest scoring student comes in and retakes the test to get 100, how will it affect the mean and median ages of the class? Okay, so the way to think about this is if we were to find the median, right, we find that middle number. So it would be 75. Well, if this 93 gets changed to a 100, is that going to change the median? No. Okay, it's not going to change the median, so I know A is wrong. We know the median will not increase or decrease, so we basically know it's going to be B. So what happens is, because that 93, which when you added, right, the mean, we add these all together and divide, we have the same amount of number of things, but we just have a bigger number, which is going to cause the mean to increase. So if we just change one of them, it's going to cause the mean to be adjusted, but not the median, okay? Which is why median can be really useful when you're dealing with outliers, because those outliers will really pull that mean or median out of the way, okay? All right, last two. And on these, as you're grading them, if there's some that you're not sure if you're getting them right or not, you can try to kind of leave them blank, and we can ask me when I come back. Like 17 and 18, we might have some issues. So we're going to look, first of all, and see if we think something looks skewed, okay? If I look at the top one here on 17, okay, because, right, we have the shape, the center, and the spread, okay? So the shape, we want to see if it's like unimodal, bimodal. With the box and whisker, can't really tell the modes. But we can tell if it's going to be skewed as well. If we look at this one on the bottom, all the data, the majority of the data is right here, so it's going to be skewed to the left, okay? So this one is skewed to the left, whereas this one, it's more symmetric, so we call that a normal distribution, right? So that's the shape. And if it was modes, we could talk about modes. So let's do the shape for 18 as well. Okay, if we look at this one, we have one mode, so this one's unimodal, whereas this one also is unimodal. Okay, so some similarities there. Is one more skewed than the other? This one you could say is slightly skewed to the right. Okay, whereas this one seems more normal, more uniform, more symmetric. I don't know if I'd call it normal per se, but it's not really skewed as much. Maybe slightly to the left, but I'd say more uniform, okay? All right, the centers. Well, median is definitely lower here. Median is higher. With all the data up here, your mean is going to be up here as well. This mean is going to be more in the center. So definitely has a higher median and mean. Same if I'm looking at this one, this more uniform, the median and mean are going to be more in the center. Skewed to the left, it's dragging it down to the left a little bit. Okay, spread is at the variability, okay, and if there's any outliers. Don't really see any outliers. This one goes from 3 to 9, this one from 3 to 13. So this one has a high variability, whereas this a low. This one from about 60 to about 72. So probably the same variability. All right, there we go, guys.